The second method I like to call the seesaw method. Imagine two people standing on a seesaw, a little kid and their mom or dad. If we put the balancing point right between them, it's not going to balance because the parent's heavier. So if I have something like this, heavier on one end than on the other, I try to balance it in the middle, well, it's not going to work. But if I put the balance point a little bit closer to one end, then it does balance. So I have to move the place where they're trying to balance. I have to move this little fulcrum nearer to the heavier person. Maybe like that. And so what we're saying is that if this person is lighter, the weight of the first person is lighter, then their distance from the balancing point needs to be farther. And if the person is heavier, weight 2, then their distance needs to be shorter. The lighter the person is, the heavier or the farther they need to be, and the lighter they are, the nearer they need to be. And vice versa. If we have somebody very far away from the pivot, then they need to be very light. If we have somebody very near the pivot, then they need to be very close. And it's that second idea. Generally speaking, we're thinking weight times distance equals weight times distance. It's this idea that we can use to answer questions like this. Think of how much of the 25% saline and the 70% saline, the volumes of those things as the weights. And then how far away they are from our goal as the distances. So I like to make what I call a mixture diagram. So we have something in the middle. We know that this mixture needs to be 40%. And I have 25% on the left, and I have 70% on the right. And the 25% is 15 percentage points away, so 0.15 distance. This is 0.3 distance. And as we're just saying, right here, since the 70% is farther away, we know we're going to need less of the 70% than we do of the 25%. Because weight times distance should equal weight times distance. And the smaller this is, the bigger this needs to be in order to stay balanced. And that's what we're going to use, because we don't actually know what these values are yet. I do know, again from the same, we kind of went through the previous example already, that I'm using 8 minus x liters of 25%, and I'm using x liters of 70%. So this is my weight. This right here, that's my W2 compared to the person there. This is my distance 2. This is my weight 1. This is my distance 1, to compare it to the people on the seesaw that we were talking about a second ago. What I mean by this is that with how far 0.15 this amount has to be, 0.15 times 8 minus x, that needs to be balanced with how far and how much the right side weighs. So 0.3 times x. So find how far each of the percentages are from the target, and then multiply those distances by how much of each of those things there are. And it's just a matter of that. Now we can do some calculations. Distribute 0.15. 15% of 8 is 1.2. So that's 1.2 minus 0.15x equals 0.3x. Move this down a little bit. Add 0.15x to both sides. 0.15x, 15x. I get 1.2 on the left and 0.45x on the right. Divide by 0.45. Divide by 0.45. And I get 1.2 divided by 4.5. Sorry, 0.45. 1.2 divided by 0.45. Which is 2.6666, 2.7. 2.7 liters. It's the same answer. And of course it's the same answer, it's the same method. Or it's a different method, but it's the same problem. And actually, once we got to this point, 1.2 equals 0.45x, that should look familiar. After all, we did get the same result here. 0.45x equals 1.2. We ultimately get the same equation, we just get there by different methods. So when you have mixture problems, decide which method you like better. Maybe try them both. If you like the beaker method, think about how much of the 25% am I using, how much of that is salt, how much of the 70% am I using, how much of that is salt, how much am I ending up with, and how much of that is salt. Or make your equation based on that. Or think about how far off is the 25% solution and how much of that am I using, and how far off is the 70% solution and how much of that am I using, and then use those values. Practice these out. Once you get the hang of it, it'll start to all come together. The trickiest part really is figuring out these values. Sometimes it's just going to be 8 and x because you're just mixing them together. You have 8 liters and you're just dumping some into that. But sometimes you might have to drain some. So just pay attention to if it's being totally just added on, or if we're taking away some and then replacing it. There's really pretty much those two outcomes. If you have questions, ask your teacher for additional help.